Hey YouTube, it's JP Dillon. Welcome to part 3 of the RCA 19-inch portable with the KCS 149A chassis. If you watched the first 2 episodes, you're all caught up. We're currently experiencing a picture but no sound, and we did change the defective sound detector tube, which made no difference. We find that if we detune the fine-tuning a little bit, it will kind of sort of come back, but not enough to be usable. And we pulled and tested all the tubes and found the mixer oscillator tube inside of the tuner to be defective. So we have a number of possible scenarios. It could be a tuner problem. It could be an IF problem, but that's unlikely because the picture is really crisp and clean looking. Or it could be solely a sound detector problem. So the first thing we're going to do is replace the defective mixer oscillator tube and then power it up and see if we get our sound, and if not, start troubleshooting the sound detection stage and see where we can go from there. And this machine uses a very odd 6KZ8 mixer oscillator tube, which I found no subs for. So we're going to go ahead and pop this one in and see if that fixes it. And thankfully the tuner axis on this is really easy. There's our socket down in the side of there. Of course, can't really see it that well here. Steady the camera a little bit. That's kind of where I'm trying to get the tube into. And so I'm just going to break it. And we're just going to feel for the key. There we go. Push it in. Pull the shield up and lock it. And there we go. Tube's in. Let's see what happens. Alright, let's see if this thing works or doesn't work here. You know something? It would be really helpful if I actually fed it some power. So let's find out what happens. Might work, might not. I got distorted sound. That's a start. Now, this CRT has been sitting a little while. Whole set's been sitting a little while. And you can see that the CRT is back to being dim and crummy. If I crank up the brightness, it just gets all silvery and washed out. So this CRT is going to need to get changed. The horizontal is also very touchy. I think that's due to this socket back here. If I wiggle it, it definitely takes it off some. But this CRT is trash. The Rejuve did not hold. The camera with its auto exposure is making it look a lot brighter than it is. This is with the brightness cranked all the way up. It just gets kind of silvery and defocused. So it's done. We got to change it out with that crisp one we got from the donor set. But we have sound, which we did not have before, albeit distorted. I'm going to tweak the detector coil here. They didn't like that. Even resetting it back to where it was, the sound disappeared again. So we're back to where we were, which is kind of to be expected. The picture looks excellent. And it's starting to get better as the CRT warms up, but this thing's really kind of trashed. So what we need to do is take a look at how the sound circuit goes together, how it works. And it seems to come and go when it wants. Okay, so let's take a look at our sound circuit and see if we can figure out anything from that. So this is our sound detector. This is our 6HZ6, which we subbed with a 6GX6, I believe. And the tubes are almost identically similar, except with a little bit more gain from this. So this technically would work better in the circuit. So what we have to do is we have to find out whether this tube is simply inadequate or whether there's more things happening outside. And I'm tending to think that there's more things happening outside, because when we swapped the tubes from an obviously bad one, there was little to no improvement made. So I'm thinking it's not going to be the tube. Now, I don't have the 149A literature on me, so what we are going to do instead is take a look at the tube data for the 6HZ6 and check our plate voltages if possible, which is going to be a bit tricky since this is underneath a shield. The shield is soldered to the board, and I don't have any tube adapters that will come up and above this. So again, this is really my complaint about these chassis, is that they're not very service friendly without extender cables. But yeah. So I'm going to check some adjacent plate resistors and things and see if there's anything obvious that would make this tube have inadequate voltages so that it wouldn't function properly. So let's take a look at the tube data first and see what pins do what. So as we can see, the 6HG6 is a pentode. Our plates on pin 5. Our screen grid is on 6 and 7, and then our cathode is pin 2, our control grid's pin 1. So probable causes: insufficient plate voltage, insufficient bias on the grid, open cathode resistor. So we just kind of need to check the adjacent resistor values and see if there's anything obvious that stands out. So with the tube removed, I'm first going to see if we have an adequate cathode connection to ground, usually through a resistor of some kind. So if we come up here to pin 2, we have a 500 ohm cathode resistor to ground, which I'm going to guess is this 556 ohm up here. And then on the other side that goes to ground. So we can say that there's a fair chance that it's probably not the cathode resistor. So the next thing we should do is see if we can find the plate resistor. The plate is off pin 5, and so that should be this guy here, or this could be a choke too. This looks like a choke. It's hard to tell what this is. So that measures 8 megs. So if we come over here to pin 5 and we go to the low side of this, it's a continuity check. We get a continuity there. So this is involved with the supply plate for pin 5 here. Now, I don't know whether this is a choke. Now see, this low side is at ground, so this is like so this here, since the low side of it's at ground, I don't think this is a plate supply resistor. So that's coming off of something without having the service literature is very difficult. although given that these other ones over here look very similar to this, I'm going to guess it's a capacitor, a very small value capacitor, tuning capacitor of some kind, because we have adjacent values like 217 here, which looks a lot like this, and then C2 here, which looks a lot like this, and those are probably tiny value capacitors. So that's probably not our cause either. And the fact that it's reading 7 megs probably says that there's not a short. So then we have to take a look at what else could be causing the issue. Now I can power this up and see if there's voltages there, but it's not going to be an accurate representation because there's no load. So let me shed some light on this, and maybe we'll move this in a little bit closer so that you can better see what I'm looking at here. Maybe brighten it up a little bit, turn on the flash there. So let's check these adjacent resistors. There should be a 470 ohm. Yep, that measures about right. And then there's one underneath here. Hard to see what this is really. Looks like about maybe 2.7K. It's hard to measure in here. Very tight. This is across a coil. Unless I'm shorting out against something. Yeah, I could be shorting out against something. It's just so hard to get in here and read what this value is. So that's reading 8 ohms, so that's likely across a coil here. And obviously without pulling that, it's going to be difficult for us to find that out. Let's see if this dropper resistor here, 6 out of 8K, it's pretty good. That's another small capacitor, it's not a resistor. We have this 82K. Yeah, 51 in charging there. So we're okay with that. I think we're getting a little far from our circuitry, but I'm just trying to be thorough here. Like this 100K is probably the plate resistor for the sound amp. That's okay there. Let's come over here. .7 out of 5K. I don't think that's going to piss the circuit off enough to care. And this should be 820, 907. Not terrible. And then this should be a 6.8K. I think we're reading across something here. Yeah, I think that's reading across this little coil here behind the meter you can't see. But so far, there's nothing obvious that stands out. Trying to see if there's anything I've possibly missed. So far, the majority of these values seem good. Now, since I do have a plate spot here I can measure from, we'll turn the set on and see if we have proper plate voltage, and then see if I can measure any of the grid points or anything like that. That would be significant. There's another one down here, this 330 ohm. .348 out of 330 is not bad. We started out okay and we slightly detuned, but the next step is to take voltage measurements of the tube and figure out what our tube's actually doing. So let me switch this to volts. Let's plug our tube back in. We'll establish a chassis ground, which I'm just going to clip up here. There's a nice fat ground tab right there. That's pretty secure. Let's apply power and warm it up. Gotta wait for those tubes. So there's our distorted sound again, which immediately goes away. Okay, so there's 15 volts on that plate. 15. Yep, that ain't gonna do it. 15 volts on that plate. I would think with a sound detector tube we'd be at least 50 or 60. So obviously that ain't gonna do it. The question is where is that voltage derived from, and how can we get it back? And without having a schematic diagram, that's not really possible in any reasonable sense. And if we take a look at our cathode resistor here, there's 1.8 volts on the cathode, about 1.9 actually. And then I can't really get to, let's see what the first grid, control grid's supposed to be pin 1, and I don't think I can access that from here. But in any case, 15 volts really isn't enough for this to conduct. And it keeps going down, which explains why the sound keeps getting worse. So that could be because there's an open transformer. That could be because the supply line to it is being interrupted somehow. I don't really know because I don't have a schematic. So I could spend a lot of time tracing this. I kind of wish I had a high voltage bias supply that worked, that I could feed that point and control the voltage upward and see if the sound came back. So yeah, without having a bunch of schematics, we're stuck. I am going to pull the board out, or pull the chassis back, and we're going to see if we can figure out anything relevant about where that power comes from. And then maybe that'll give us a better understanding as to how to troubleshoot it before going to dig up a schematic. Okay, so I've got this thing apart and I'm tracing things out. And I noticed a couple points, but again, without having it energized, it's really difficult. So I simply removed the horizontal output from the circuit, disconnected the yoke and the CRT. So I'm going to see if I can operate it this way. And maybe that will help us better troubleshoot things, not having the high voltage hooked up. Question is, will it operate? Because right now I got no sound, no tuner, nothing. So maybe it's a scan-derived thing. Yeah, no sound, no nothing. And it might be that it derives the voltage for the tube off of the scan. Yeah, because now I got nothing. No voltage there at all. So that's scan derived, which is interesting. So looks like we got to hook stuff back up, and that ain't going to be easy to run this thing and troubleshoot it. But anyway, here's what I found. The pin 5 goes through the transformer and then is supplied by this wire here, this gray one, which you trace back to this point here. And it comes to the low side of this 390K, and this measures 440K. That could piss it off. I doubt it. But then the high side of this resistor goes down to this junction point here, where we've got a 1 meg, which measures 1.2, and we've got another 470, which measures like 490 or 5 something. But it looks like a lot of these voltages are scan derived. So it may be that they're low current enough that they could require precision resistors. But like I said, without a schematic, there's no way to know for certain how this voltage for the detector tube gets its juice from. All these adjacent resistors I've checked here in the scan circuits are okay. And the resistors on the power supplies are okay. So the fact that this is scan derived, something we need to pay attention to. And this Sprague orange drop, which is part of that circuit, this feeds into the high side of this down here and then back up to where the 390K is. That's been replaced, so who knows if that was done correctly. I think ultimately I'm going to need a schematic, but what I am going to do is change these high value resistors and see if that helps me at all. So after changing that resistor, which was a bit higher, that really solved nothing. We're kind of back to where we are. And if you're curious, we're back to our 15 volts again, slowly decreasing over time. So based on the fact that that's scan derived, or at least it appears to be, my thought is that there's either some high frequency component like a capacitor that's snubbing that network, which I could see there being a thing here too, like one of these capacitors is leaky or it's passing high frequency, pulling down the voltage. But again, without a schematic, I don't know what these values are supposed to be, so we're going to get our hands on that, and then we can better troubleshoot this. But definitely low voltage at the plate of the sound tube is no good, and that's likely the reason why our machine is misbehaving. So let's get a hold of a schematic and see if we can do better on this one. Alright, so fast forward a little bit. This finally came in the mail. It's SAM 734-3. This is the KCS 149. And this one pictured here has a remote control, which is kind of cool. If I can remember the name of the place that I bought this from. Let me put the camera down and get this apart. I'll put a link in the description for them. But I bought two things from them. Sam's wanted like $24 for this, and I got this for $10. It's the original Sam's Photo Fact. There's the remote control chassis, don't need that. And it gives you the locations of everything, which is nice. Yeah, let's see here. We can get our schematic diagram and see how this sound detector tube gets its juice from. There we go. Okay. So remember how we were getting 15 volts on pin 5. It's supposed to be 190. And it is, looks like it is sweep derived because it comes right off the boost. So it comes off the boost through a 1 meg 2 watt resistor, and then that 390K, which I changed out, but that really didn't fix anything. So it's strange here. You got point A, which is 280 volts, but that goes through a capacitor. So why do they even have that there? It's not feeding anything. And let's see where they get the boost voltage from. Probably right off the damper. There's your vertical output. There's that. Yeah, so 6AY3 damper. I guess they just derived B-boost right off the flyback. Well, anyways, let's go back up here. So you go through the 1 meg 2 watt resistor to the 390K, and then right over to pin 5 there. So the fact that we have no voltage on the low side of that, we need to check the high side of that 390K for voltage, which is not really accessible in the assembled form that it is. But my thought would be either A, we've got an open 1 meg resistor. We could also have a defective C44, which could be pulling down the B-boost, because after it goes through a 1 meg 2 watt and it goes through that 390K, that's going to drastically reduce the available current for the circuit. So if that cap is leaky, that limited current is going to make that 190 volts disappear real quick. So the .001 could be bad. The 1 meg could be open, since we've already replaced R58. Now, if C46 is leaky, that would also dump voltage through the volume control to ground. That's unlikely, but not an impossibility, because it's a 1 meg volume control, and so you'd see significant voltage on that volume control if that were the case, and it would probably get it pretty toasty, since I don't think it's more than about a half watt. And I don't remember any sort of acrid smells or volume control being noisy with DC on it, so that's probably not it. So we need to take a look at C44 and R59 as far as components that would be responsible for making that 190 volts go down to about 15. And yeah, the tube could have a short, but what are the chances of replacing the shorted tube, which we already did with a good tube, and that not changing? It's probably not the tube. So yeah, let's take a quick measurement here. Okay, so we come down here to the 390 that we replaced, and then on the low side of that, that goes down to this junction point there, and then you can see our 1 meg resistor, which is right there. So let me take our meter, and let's go down to the 1 meg resistor. We got 1.2 megs there. So in theory, that looks pretty damn happy. I highly doubt that a 200K difference is going to cut that voltage down enough to where it's going to reduce it to 15 volts. So, yeah, I'm not believing that one. So, it could be that I'm reading off of a signal of some kind. Or, yeah, signal. I'm reading off of another component area of some kind, and I could be getting a false reading here. It's unlikely. So let's see here. We got this 0.12, which feeds off of that point there. That's not part of it. All right. Yeah, so high side of this, that comes off of this choke here. So let's follow this back up and grab this. So the low side of the 390 ohm resistor comes up this line and then goes to this point up here. And if we come on the other side of that, we should see somewhere here our 0.001. Yeah, don't mind me, I'm just blindly looking around here. Okay, am I in the right spot? Yeah, I am. That comes in right there on that little spot there. And you see I've traced it out. That's interesting. So, damn it. Okay, so the supply line in question, I've got it traced out in red here. It comes right over to pin 5. Right over to pin 5. There's no... Oh, I see. This capacitor shunting to ground. That's why, because I'm not paying attention. So we've got this up here, which I can't see because it's got gunk on it. Let's clean this off a bit if I can. Nope, don't want to do that either. Yeah, I can't read what that says. And there's nothing on the board here that tells you if it's C whatever. They do that for the resistors, but not for the capacitors. And I'm trying to figure out where this magical 0.001 capacitor is. But that's the only thing. No, that capacitor goes on pin 6. That's not going to be it. So then we come back over here to pin 5. Yeah, I don't know where this is. Unless... maybe that's it. Okay. Because this disc capacitor here, which is fairly well stuck, that seems to go to ground here. And so what I'm going to do is I'm going to validate the low side of this capacitor is at ground, which it is. And then the high side is on that same line that feeds in from the B voltage. So that's the 0.001 that if it were leaky would pull down that voltage. But you know, that's like a really rare failure. And let's see here if they have a resistance measurement chart. Usually there's a resistance measurement chart. You know, you're supposed to take a resistance check from ground, parts list, miscellaneous parts list. Yeah, I'm not finding it there. Go on the back side. Here we go. Measurements, and forgot what we were already. Don't mind me, just shuffling around like an idiot. Detector's V6. Okay. V6, pin 5 should be 1.4 megs to ground. That's what they say. So let's do these resistance checks here. And I'm going to pull the tube out. And we're going to see here. All right, so that's going to be pin 1. Yep, that's about right. Pin 2 should be 560. 554, that's pretty close. 3 and 4 are filament lines. Pin 5 should be more than 1 point, what is it here? Should be more than 1.4 megs off ground, which it is. And pin 6. Pin 6 should be 14K, so that's about right. And rising. And then pin 7 should be 470K. Something's still charging because it's not going to tell me what it is. But nominally, that looks good. Now, a point of curiosity is maybe to take our volt ohm meter with the 22 volt battery and see if we get the same resistance off pin 5. So let's take a look here. And if we go to pin 5, come on now. We're on the R times 10K scale. So that's about just about a meg. So that's about right. And about stops there. Let's go back and check our 1.2 meg ohm resistor here. Yeah, that's significantly less with that. That's a whole different reading than we were getting with our DMM. Now that I put a voltage on it, it's probably going to be different. So it may be that that's open. We just can't see it. Yeah, see how there is voltage there, and now it's slowly going back down to its 1.2 meg. Switch polarity. That's pretty hell-bent on that 1.2 megs, isn't it? So we still haven't made a determining cause as to what really is pulling that voltage down. So I think the next thing I'm going to do is I am going to replace this capacitor, this 0.001 ceramic cap, because let's see, reading across it, now that would have given us the same value since it's in the line, but the likelihood of this being bad is a lot less than that 1 meg ohm resistor being bad. And I really have to desolder it and take it out of the circuit to know for certain. But yeah, so that's what we're going to do next. Alright, so there's the bugger we're going to try to lift one side of. And I hate messing around with old terminal strips like this because the likelihood of one breaking or failing is pretty high. They're old and brittle. Alright, let me get my solder wick and get some of the excess solder off there. And I'm going to try to bend the loop on the resistor and get the resistor loose. Yeah, this ain't doing well for me. There's just so much solder on this terminal. Just keeps wicking it up. I may need to get my little solder sucker. ways. Let's see if I can get the loop up enough to where I can bend it. There we go. Probably can't see this on camera, but I'm just going to bend this out enough to where I can get this resistor out of the circuit. All right. Now we can actually test it with some form of accuracy. So now I'll hang my meter across it. It says 1.3 something megs. They want it to be a meg. So an additional 300K might piss off the circuit. But 190 all the way down to 15 volts, that doesn't seem right either. But I think for grins and giggles, I will change that part. And then let's see about desoldering the little 0.001 capacitor that's inside of here. So that's the little bugger right there. That's listed as a 0.01 on the part, but the schematic labels it as something else here. Yeah, they list it as a 0.001. And this is for the KCS149A, so you're not sure there. Should I put a 0.001 in there, or should I put a 0.01 in there? Because, yeah, obviously what I pulled out here ain't what was supposed to be in it, according to that schematic, unless there's some sort of change I'm unaware of. That's a sprayed part, and it looks legit. If we look at the other disc capacitors in here, it certainly looks like, hell no, we have, these are different values of brand, and that one's completely unmarked. Let's turn on the light here. Yeah, these are just non-labeled, different brands there. That one's non-labeled. Of course, I couldn't see what was on that one either. So I don't know. Decision is decision. Should I put the schematic value part in there, or what I pulled out of there? I'm tempted to go with the schematic. Just out of curiosity here. I don't think it'll register anything, but let's read across this part. It blips there for the tiniest second as it charges. But yeah. Short of putting a big voltage across that, I don't think it's bad. But we're going to replace it anyways. And since it's a sprayed part and not an original, or who knows, maybe it is. Anyways, I'm going to put what's the 0.001, which is listed on the schematic in there, and go with that. Okay, so fast forward a little bit. What we've done is I've replaced the 1 meg 2 watt resistor, which was reading about 1.4 megs. I also replaced the C44, and it had been replaced previously with a 0.01, so we put a 0.001 back in. That 390K was replaced. And so I'm trying to eliminate all the probabilities that could load down that circuit. I also changed out C45, which is that 0.12 there. And the reason why I did that is because there could be a chance it's leaky, and it's pulling that to the potential of the 280 volt supply, which would be far too low. And so with all of this, we're going to power this thing on and see if that made any changes. And you can see my new capacitor and my new 1 meg resistor there. And I put some clip leads in. The clip leads, since this is such a pain to troubleshoot, the clip leads are going to monitor the voltage at the low side of the 1 meg resistor. And also at the low side of the 390K right before it goes to the plate, to see what the voltages are going to be before we get our hopes up about troubleshooting this, because I'm about out of ideas. If we still got a low voltage, then whatever's supplying that boost may just not be enough current. And I was trying to locate where the boost line is here. I think it comes off the horizontal out. Yeah, so we come off of the flyback, or that's the boost source. So it's hard to say where the boost source is. Usually it's generated right off the damper diode. And I'm trying to see, there we go. Yeah, so that's the 6AY3, the 280 volts. But yeah, anyways, that goes through the flyback, and that gives us our 750 boost. So there could be a bad secondary in the flyback that's not providing the correct current. Or the damper could be bad, but then we didn't have width problems on the screen, so that's not very likely either. Anyways, lots of pondering. Let's button it back up, turn it on, and see what our voltages are now. Alright, so let's fire this thing up, and let's see. We're going to monitor our B boost first. Here comes the sweep. So this is on the low side of that 1 meg resistor. 195 ohms. Or excuse me, 195 volts. Oh, that CRT is getting worse. Yeah, it's just done. That's brightness at max right there. It's just so dim. If we get the sound problem fixed... See, I don't hear any audio. I don't hear any audio at all. Not even static. Alright, so 194 volts on the low side of that 1 meg resistor. Let's go to the low side of the 390K. And there's our 15 volts. Now let's see what happens when we remove that detector tube. Just completely take it out of circuit. Alright, so now we got 673 volts, so there's no load on it whatsoever. So the tube is definitely loading that down. But for what reason? As soon as the tube warms up, we had sound there for a moment, and then the voltage goes away. Now, if we want to peg that capacitor that goes between the plate of the output of the detector and the grid of the audio tube, what we can do is yank the audio tube and take that load out. As you can see, there's no change there. So it's not on that side of things. But 14 volts, that ain't doing it. Now we can briefly take the voltage from the 1 meg resistor and directly apply it to the plate. But that really doesn't change things. It goes from 15 volts to 17 volts. And that pisses off the resistor for sure. Only a 2-volt increase. So, for whatever reason, something in this circuit, this plate circuit, just ain't right. So let's see if there's any more possibilities as to why this could be pissed off. Because it's obviously loading down this circuit. We don't know why yet, it just is. Let's kill the power there, And let's take another look at the schematic to see if there's anything else. So as we saw, removing the 6HZ6 completely changed everything about how the circuit behaved. Now when I took the resistance measurements per the SAM, everything from pins to ground were cool, everything was good. But with this tube in circuit, it just rips on that. The high side of the 390K is cool. We got 194 volts there, which we should be seeing there. But to go from 750 to 190, that's a big voltage drop. And if we go across the 390, that 14 volts only goes up 2 volts. So there's a huge voltage drop that's occurring as a result of that, that tube. I'm going to move the jumper to the high side of the 1 meg to see if we still have our 750 volt boost there, to make sure that we're not losing the supply. I mean, like I said, there could be something wrong with the flyback and the supply is not getting there. Yeah, and also what I might do is jumper briefly the 280 volt supply to the 390K and see if we get voltage there, if the flyback is in fact at fault. But let's see what our supply voltage is at the top of that 1 meg resistor before we get too crazy about it. Okay, so I'm going to turn this back on. Now we're monitoring the voltage at the high side of the 1 meg resistor at the boost source. And remember, at the low side we were getting 194 volts. Let's see what the high side looks like. Yeah, so our 700 and something boost is totally intact there at the high side of that resistor. And at the low side we got 194 volts. So all of that drop is occurring across the resistor. And then again, from the 194 volts to the low side of the 390K, we've got a whopping 15 volts there, which doesn't do us any good. So there's definitely something wrong in that circuit. Let's take one more look at, maybe there's an error on the schematic, but why would it have worked for years and not work now? So, yeah. Okay, so when it all comes right down to it, I think I've been chasing my tail on a bad tube. Let me tell you why. This was a sub from the schematic of the KCS146A. Said it could either use the 6GX6 or the 6HC6, both of which were used depending on whether it was a UHF model or not. And this one has marginal emission, but it's not terrible. There's no shorts or nothing like that, but obviously it doesn't work. Let me show you something else. This is a 6AU6, not designed to work in this application. Same electrical pinout, operates at a much lower voltage, usually around 90 volts, 100 volts, something like that. And usually not used for a detector. So I'm going to pop that guy in there, and we're going to turn this on, and you're going to notice something about the voltage of the supply line. Remember how we were getting 15 volts? Watch what happens now. We have sound, but it's very quiet. And we have 60 volts and dropping. Now, I can't run this very long because the tube is getting stupid hot right now, because I've already briefly tested this. And when I turn it off, we get a nice oscillation squeal. So, not designed to operate in this circuit. But the fact that we got our voltage up really suggests that I just need to knuckle down, spend the money, and replace that 6HZ6. And very likely this thing will get going. Yeah. We also notice that our CRT is dim, so let's check that against the CRT tester now. Back on the Beltron. Yeah, the emission comes up, but it's definitely, the screen says the cutoff is like 0. It's all milky and dim and blurry. So, yeah, I think that after we get the sound thing sorted out, we'll put the other picture tube in it, because this one's just done. It's not holding the rejuve, despite what the cathode emissions say. It definitely, the screen looked like garbage. Alright, I gave it another tap with the Beltron. When I first rejuvenated it, I noticed it was still getting rejuve current even with no heater and with it, cold, so I figured there might be a short. So I tapped on the neck and saw some lovely sparks inside, and then the rejuve process went better, so let's see what it looks like now. We might have a nice bright one now. Oh, much sharper. That's with the brightness turned all the way down. There we go. Alright, well, let's see if that holds. Let's see if that one holds. That's right, no audio because I took the tube out. Yeah, so I'm going to order one of those 6H Z6s. Just get the right tube. And we'll give a shout out to Jim Cross. He's the guy I order my tubes from, and he always delivers. So we'll grab that, get it in here, and see how it goes. But until then, thanks for watching.